So that was a quick one coming in from our sponsors, Coconut Grove Regency Hotel and GN Bank. Moving on straight into Tech Innovate.
This is TechSpot, and we are on the segment what we call Tech Innovates. This is where we bring you interesting, innovative ways where people put together simple things that they can use at home or wherever they find themselves in. Today, we have again here Felix, who's going to take us through what we have for you. But just a quick recap of what we did last week, where we talked about on-air light for studios. We basically assembled it here and fixed it right at the doorpost of the studios. Today, we're continuing with still lightning, but this time we want to get a feel of what lighting system does. Have you ever wondered how security lights, home lights, and even street lights goes on and off without anybody switching them on? Well, there is a simple gadget that helps us to do all these things, and that is what we want to talk about today. So today again we are in the studios and the working bench of Felix, and Felix, you are welcome.
Thank you.
So Felix, what do you have for us today?
Today we are going to see how we can control our lighting system automatically. So normally we call it the photo switch or photo cell. So this works with sunlight. So during the night when we have no sunlight and the weather is very dark, our lights will come on, and in the morning when the sun starts to shine, then it turns our lights off.
Very well. So, I mean, this is very handy because we are in the era of doomsday where you need to conserve energy. So in conserving energy, you don't need to be at home, leave your lights on, but it can just go off and on by itself depending on the density of the lighting system that we have, right? Okay, so first of all, can you just give us a brief theory of what this whole thing is all about, so that, I mean, if you're an electrical engineering student, you get the theory behind what we're doing. So he's going to take us through the theory behind what we're going to do today.
Okay, so with what you're going to do, you need just a few components. It's just a very simple circuit that we use to control some LED lights. So what you need is a photo transistor. You also need a MOSFET, a resistor, then your LED and a power source that we use for controlling it.
Yeah, I can see that you have your working bench, a sheet of paper. You've drawn some diagrams on it. Why do you normally use those diagrams before you come practically to do your stuff?
Before you come out with any design or with any anything that you create, what you do is you sit down and see how you are going to connect the components, because how you connect them will tell how they are going to work. So you first sit down, then you use what we call the circuit diagram. You draw it and connect all your components. Then now with the help of IT, we have simulation softwares. So you can use your simulation software, you draw your circuit design there, then you simulate it to see how the circuit is going to work. Then after, you pick your components, then you connect it as you did it.
That's very good. So just walk us through the circuit system for what we want to do today.
So with our circuit system, we have the MOSFET, which is a transistor, who is going to basically do the switching for us. Then we have the photo transistor also. That one is going to do the detecting of the light. Then we have a resistor, which is being connected between the battery, that's a 12-volt battery you are going to use, and the photo cell you'll be using in series. Then the transistor it has 3 legs and is known as the gate, the drain, and the source.
Hold on. You've mentioned a whole lot of terms that someone watching us would like to understand what all those things. I've heard transistor, I've heard resistor, I've heard photo transistor. Please take your time and just explain those terms for us.
Okay, so let's start from the beginning, which is the battery or the source. The battery is what is going to generate the voltage that we are going to use. So basically that will be our power source that we need for the circuit. Now you come to the resistor. The resistor, if you demonstrate with something simple, is maybe the water hose that we use at home. You connect the water hose to the tap, then you open your tap, water flows through it. That is how current flows through the circuit. Now, if maybe you want to stop or reduce the flow of the water at the end, normally what we do is we squeeze the water hose, then it will reduce the flow of water coming out. So the same way in our circuits, sometimes the components that we use, they are so delicate or the sources are so high that if we connect them directly, they are going to get bent or spoiled. So we put a resistor there, which is going to be like your hand you are using to squeeze the water hose. So it's going to reduce the flow of current in the circuit so that it will not damage the components at the other end.
That's very, very interesting. I've learned something today. Yeah, the water hose in relation to a resistor. The next one is
the phototransistor. The phototransistor is also a type of transistor. Basically, all transistors have three legs, known as the collector, emitter, and the base.
Collector, emitter, and the base.
So now, this phototransistor has only two legs. It looks like the LEDs that we use. It has only the collector and the emitter. The base is the part which detects the lights, that's the sun rays, as they hit on it. So the base is basically the one doing the switching. So if the light rays hit on the base, which is the part sensitive to light, it causes some amount of voltage to flow through the emitter. Then with that, the switching also occurs. Then we come to the MOSFET, which is metal oxide semiconductor field effect transistor. The MOSFET has three legs, the same as all transistors, but the legs of the MOSFET is labeled differently as the gate, drain, and the source. The gate is the same as the base. That is what does the switching in the MOSFET. We have the drain, which allows current to flow through it. Then we have the source, where the current leaves the transistor.
So fellas, we've learned about two things, the resistor and the MOSFET. But you mentioned LED light. I mean, a lot of people don't really understand what LED means. Can you explain a little bit about that for us?
LED stands for light emitting diode. It is also a type of component that we use in our circuits. What a diode actually is a component that allows current to flow through in only one direction. So if current flows through it, it can't come back. But this type of diode is a type that when the current flows through it, it emits light. It gives off light. That's known as the LED.
Very well. So viewers, we've gone through the theory behind what we want to do today. So Felix is going to now show us the real components so that we can see what it feels like. Because a lot of us, when we are studying, we only think about the theory, but the practical aspect of it is missing. But TechSpot is there to be able to bridge the gap between the theory and the practical aspect of things. So he's going to show us practically what he has mentioned in this circuit that we want to use as a light switch, right? Okay.
This is a MOSFET you are going to use for the circuit, LED, the resistor, and the photodiode. The phototransistor. We also have here our 12 volts battery, which will serve as our source for the circuit. Then the PCB will do our connections on. A PCB stands for printed circuit board. This one has the holes and there's a copper base in it. You put all the components on it, then you solder them to the wires that you use for the connections. But when we take the PCBs from other electronic devices, those PCBs are manufactured at the factories and they have machines that they use for it. So those ones, they don't use wires for their connections and their components. So the component design on that is a little bit different from this one, because this is handmade and that one is sort of machine made. Yeah.
So can we go on to exactly what we want to be able to connect onto the PC board and stuff?
So from our circuit diagram, we know we have our 12-volt battery source, then our resistor. This is a 100 kilo ohms resistor, and this resistor is going to be between the positive lead of the battery and the positive lead of the phototransistor. Then we have the gate, which is going to be the middle leg of the MOSFET, tapping into the connection between the resistor and the phototransistor. Then the source is going to be connected to the neutral. Then the neutral part of this will also be connected to the battery. Then we have the positive part of the LED connecting to the drain of this MOSFET. Then the neutral also goes to this. So when it happens that there is darkness over this phototransistor, the circuit will turn on, and when it is open to sunlight or any source of light, the circuit goes off. So we are going to arrange these components on the PCB. These are LED, with the shorter lead being our negative and the longer one being the positive. Okay. So we put that one also on the PCB. Then here we have our photo transistor. That one the same way, with the longer lead being the positive and the shorter one also being the negative.
So I can see you arranging them in a particular order. Is there a special way of arranging those things on the PCB board?
How you arrange them depends on your circuit diagram or your circuit design. And how you arrange them also affects how you are going to finish it. So depending on where this LED is going to be and where this transistor is also going to be, then you can use it to do your finishing. So how you arrange them depends on whoever is doing the circuit. Then we have a 100 kilo ohms transistor, which will also be here. So this transistor, this resistor, the 100 kilo ohms resistor, is in series to the photo transistor here. Then the gate of this MOSFET is being connected to the resistor and the phototransistor here. Then the drain is also connected to the positive lead of this LED. Then the source and the negative of this and the negative of the phototransistor also is being connected to the negative lead of our battery source. So after all these connections are done with the help of your soldering iron and a lead, then your circuit is done. So whenever there's darkness over this phototransistor, your LED lights up, and when there's light, the LED goes off.
Aren't you going to connect any electrical wires to it for us to know that definitely there has to be some wires?
Yes. Those will be done at the back of it. Okay. With our photo switch that we have, this can be implemented in the street lights, which now some of the street lights around are using it. We can also use it in our homes for the security lights that we have outside. We can also use it in the gardens. Some companies can also employ this, such as the hotels, the motels, restaurants, and other places. Also, you can connect it to any type of lighting system that you want it to be controlled by the daylight or at night time. You can also connect it to other type of devices. It can even be a motor or any relay that you want to use. So depending on how you want to use it, this circuit can be very useful.
Okay, Felix. What is the lifespan of this kind of system when you are implementing it in a hotel or home or whatever?
The lifespan would depend on the components in use. In this circuit, we are using a battery to support the LED. So if it happens that all the components are still intact, but the battery is off, it dies out, it means that the circuit is dead. So unless you recharge the battery or change it, we cannot put on an LED. Even if there is light or darkness, the circuit will not work. But in our homes, maybe we are using the 240 volt system, so we connect it to our lighting systems that we have. So that one, so far as there's power in your circuit or your wiring in your home, still the circuit is going to work. Until any of the components in this circuit gets damaged, your circuit will still work.
Well, that's very good. So viewers, I want you to join us next week whilst we continue to build this board. And there is more for us to do, right, Felix? There's more for us to do, trying to connect to the battery, the wires and all that, and also test how this thing really works. And I think we're going to learn a lot next week. So join us same time next week for us to finish building this light switch using the photo transistor. It has been TechSpot, and this is Tech Innovate part of it. My name is Kramer.
As you can see, I still have in my hands my gamepad, and I just can't wait to resume playing. This has been TechSpot, and my name is B-Main. Don't play games as you drive. A big thank you going out to our sponsors, Coconut Grove Regency Hotel and GN Bank. Also to Kramer for coming in with an insightful analysis about what games are and what have been happening in the world of game. From Team TechSpot, we say think twice and act twice. That game was Charlie. Out of 20, out of in natural. This has been TechSpot, but don't forget to drive as you play game. Don't do that. It's not quick. Drive the back.
We have the MOSFET, which is the metal oxide silicon.
Don't play games while driving. No good for you.